Welcome everybody to a new brand video. We will be talking about research methodology and its numericals, and particularly of chapter 6, which is one of the new or different numerical we'll be having. We'll be talking about Z score. We'll be talking about sigma scale, or we call it Z scale, doesn't matter, it's the same thing, and T score. The thing is, once you know Z score, there is no necessity to understand much of the T score. It's completely the same thing. So we'll be studying about that. So let us start with, I will say, percentile. Okay, so I will be writing here. It's pretty difficult. I don't have a board. Somebody send me money. I need to buy whiteboard for the content. Okay, percentile. So what is percentile? Percentile, in simple words, let us take an example like height. Let us suppose someone says to you, your height lies in 80th percentile. So it means that 20% of the people are taller than you, right? And 80% of the people are shorter than you. That is what percentile is. Percentile gives you above or below. Okay, that is what percentile is. So yes, talking about that, let us now move to Z score. So we will be using percentile to calculate the Z score. So I will start with the Z distribution. I'll help you understand first. As you know, this is Z distribution, right? So here is the mean. Usually for the standard Z distribution, this is the mean, this is the origin, where mu is 0, right? And the distance from here to here and here to here is what we account for standard deviation. Meaning, if somebody says that the Z score you got is 2.3 sigma, right? The score is 2.3 sigma, or simply the Z score is 2.3. It means that if the score is made into a normal distribution, then the answer you got, right, is 2.3 sigma away from the mean. It is a way of measuring things. It means if I have to tell how far you are from the mean, right? Just like in percentile, if the average height is maybe 6 foot, that what girls in my class think. Okay, the average height is 6 foot, so it means that if you are 6 foot 11, so how far off you are from the 6 foot can be told in the standard deviation, right? So like 2 standard deviation away, it means that you are away from the mean 2 standard deviation. So that is in general Z score. So if you have to define in exam what Z score is, Z score is the score expressed in terms of standard deviation. So score, if you have score, right, that is expressed in standard deviation of some normally distributed data, that is called Z score. I might keep note later on for the definition. I will not hassle you with that. So let us twist this page first. I am very poor. Somebody needs to buy me. Okay, so let me see. So talking about Z score, what is the use of Z score? Simply getting to that. So what is Z score is if you have ones for one value, right? So suppose if the mean is suppose 6 foot, right? Your height is maybe x value is 6.7. So the Z score will be of course x minus x bar upon sigma, right? This is called Z score. How far away you are from the mean in terms of standard deviation. But if you have a lot of values, right, so maybe tons of values, then if you give Z score to each and individual value, so maybe like boy 1, boy 2, boy 3, boy 4, and if you turn all their height 6.5 inch, 6.3 inch, 6.2 inch, 6.5 inch, something like that, and you turn every value into Z score, maybe 2.3 sigma, 2.5 sigma, 2 sigma, 1.8 sigma, right? So we are telling how far you are from the mean value, then this all is called sigma scale. Okay, so if there is one value for one particular, it is called Z score. If there are a lot of values, that is said to be sigma scale. So I will straightly go towards numerical. So let us get into the numerical. Suppose I'll help you create Z score, how to do that. So there is a pretty example in the book, you can see. So as you can see, there is percentile 5, 10, 15. As we talked about percentile, what percentile is? Percentile is how far you are off. No, percentile is above and below, meaning 5 percentile, meaning there are 95% better people out in the world than I am. That is what pretty my father thinks. So yeah, going on, there are a lot of values over here, 5, 10. These are percentile. Okay, so percentile meaning how far off you are from the mean, mean the center, and the z score. So let us go on with that. Suppose this is the mean, right? This is standard, what we call standard normal distribution. So suppose you are in the there is a question to be solved, and A is solved by 95% of student, right? So meaning 5% of student didn't solve. Yeah, just like the problem between her and mine, just didn't solve. So the thing is, if you try to solve this numerical, we will go into the assumption. This is very good important assumption. Remember this. This is where weaker student lie. I will go down here. Weaker. The left side is usually the weaker, and the right side is the stronger. I say, the one who can solve the problem. So meaning 95% students solved, meaning this is the part the student didn't solve. So like 5% of the student lie here, like who didn't solve this, right? So this is what we are interested in. So to get the z score, so if you want to if you have a percentile called suppose 95%, okay, you have to find for percentile 95 a z score. Okay, then what you do is you get 95, it means 5% of this, right? This is pretty bad, like not knowing the answer lies here. So how far it is from the mean? So it is, as you can see, this is 0.45 area. Okay, as you know, the area is 1, this area is 0.05, so this area will be 0.45. So there is a table. I will go into the table. As you can see, this is the table, right? So this area is what we are interested in. This area has to be, as you can see, in the 0.45. So this is 0.45. To find the 0.45 value, you will go here. 0.45. So 1.65. So this is the point minus 1.65. As you can see, this is in the left side of the graph. So this will be negative. So it means that at 1.65, the area after that is 0.05. So the z score for the 95 percentile is 1.65. For the 5%, it will be minus 1.65. Just because for 95 percentile, we have to find this area, right? For the 5 percentile, you will have to find this area. So in this way, we calculate the z score. So let us try to do a numerical and you will understand it a bit. I'll try to zoom out. Let us do a numerical for you to understand, and this took me a lot of time. I hope somebody is watching at this point of time. If you are, please comment. I will know at least somebody is watching. So let us take an example from the book. Okay, so we have a table which is A, B, C, D, E and F. Okay, so we have 90, this is in 95% people solved the question. Another is 80% solved the question. I'll try to zoom in. So 80% solved the question number B, and 55 solved question number C, 40 solved D, 15 solved E, and 5 solved F. Okay, so we have to find a z score. So how do we get the z score? So let us talk about 95. So let us go again. As you can see, this is normal distribution, right? So 95 percentile will be this is 95. So like 95 people could solve it, 5% of population didn't. You can take this, you can take this. So being in the 95 percentile means 5% of people didn't solve this. So as you can see, this is 0.05 of area, right? Who solved are on the right, who didn't solve are on the left. So as you know, now this is 0.05 and this area is 0.45. from the table to find the 0.45 area as we did previously. This is 0.45 area. From the table we can see it is 1.64. Being on the left side, it will be minus 1.64. So 95% means it is 45% below the mean, right? So it means 0.45 area, right? So this score on the table will be minus 1.64. Similarly, for 80%, it means that in the normal distribution, I'll do it above as you can see. So in the normal distribution, 80% means 20% didn't solve. So right, it is 20% didn't solve. So this will be 30% because this is 50, right? So it is 30% below the mean. So it means minus 0.3 area. So minus 0.3 area will be minus 0.85. How to get this again? If you go to the table, you need the area here to be 0.8, right? To get 0.8, 0.3, sorry, 0.3, you have to go to 0.3. So if you go, here is 0.3, this value. So if you go 0.85, so in this way you get 0.85. Similarly for 55, this is 55%, so it is just 5% above the mean. So here it is, right, 55. So it is, the area is very small, 0.05, and on solving this you will get n minus 0.13. In similar way you can keep on solving. So in this way you will get an score. This is called Z score, which I will not go in detail. So the main focus of this is you could do it from the example what better have you taught. But the thing is, if you have any question, you have to see first the percentile, meaning this is the area you are interested to look. Unsolved area, this is the area your table has, and you get the Z score from the table. First you have raw data, you change the raw data into percentile ranking, then the percentile ranking is changed into Z score by the process which I taught, which is how far away from mean, right? And then the Z value for the area, and the Z value is the Z score, and for all Z score we make Z scale. Yeah, that's pretty much it. I don't know if I've done justice. I tried to make it pretty quick. So if there is necessary for a video of percentile ranking how to do so, I'll be happy to make it and make it a better video. If you do comment, I will do the hard work of going and getting a whiteboard. Please help.